Okay, thank you very much. And yeah, so my name is Yan, and a while back, I helped a client build this AI-powered code reviewer using serverless technologies and Amazon Bedrock. So we launched a product called Evalure last December. If you go to evalure.io, as you log in, you can see like a trend in terms of how many issues we found in your repos, issues like security, vulnerabilities, performance, anti-patterns, and more. And you can have a personal account or a team account where you can invite other team members and so on and so forth. And you can add both your public as well as your private repos. And once you give us access to review and scan your repos, we will then review every single PR that you create, that you open. And we'll give you a summary of the problems that we have found in your PR. And for every problem, we will add a comment to the relevant lines and files, like this one here, where we identify the potential remote code execution issue, risk from you using YAML.parse on a potentially untrusted YAML content. We're also going to give you some recommendations on how you can address these problems that we've identified and give you a quick fix that you can commit to your PR with a single click of a button. So with this talk, I'm going to tell you how we built it, what our high-level architecture looks like, and why we decided to go with serverless and specifically Amazon Bedrock to access those AI models, and also what we have learned through this whole process of building an AI-powered code reviewers about the current state of LLM technologies and some of the limitations and the practical sort of challenges that you may find. So my name is Yan. I'm an AWS Serverless hero and been working, building stuff on AWS since 2010. And since 2016, I pretty much entirely focused around building with serverless technologies on AWS. Nowadays, I spend half my time working with Lumigo, which is the best observability platform when it comes to building stuff on AWS, especially when you focus around serverless. The other half of my time, I help other companies adopt serverless and teaching them all the things that I've learned along the way and avoid all the problems through consulting and training. And sometimes I go in and help companies and the clients build and launch their MVPs, like in this case. So I want to start with just a quick high-level architecture so that you can see how our whole system is kind of put together. So when a user opens a PR, we find out about the PR through a webhook event from GitHub, where we will capture that and we'll push that into an EventBridge event bus with a custom envelope so we can capture a bunch of metadata that we care about in our system. And that event will trigger a Lambda function that we then use the Bedrock to review the files that's been changed in your PR, and then we're going to save those results into a DynamoDB table. We use Bedrock in this case, but in case there's a problem with Bedrock, which could be issues with throughput, which I'm going to talk about later, or it could be issues with, permissions and other problems like that. So we also then fall back to using Anthropic API directly to access the Claude models as well. I'll talk about one of the really important reasons why we decided to have this fallback in the first place. So that's on the back-end side of things. On the front end, on the evalure.io website, is hosted on the cell, and you can see the history of your PRs, the results that we have identified, issues we have identified in your repos. And to support the front end, we have an AppSync API, which is a managed GraphQL service from AWS that uses a combination of DynamoDB and the Lambda resolvers to be able to fetch information that's going to feed the front end. We decided to use a Clerk for user management and authentication because it has great integration with Git providers like GitHub, GitLab, and so on and so forth, and Bitbucket and other people like that as well. But also importantly, it has got many UI components that you can just use out of the box. Plus, it supports the whole sort of creating and managing organizations, inviting users, as well as managing the memberships and roles, and so on. So all of that comes out of the box alongside those UI components you need, including the UI display that you see here, which means we can get a lot of it just done out of the box, and it saved us a lot of time. And it was important for us because we wanted to go from idea to production quickly to be able to validate is this a market, is that going to be a market fit for us? But because we use Clerk, our AppSync API also needs to have a Lambda authorizer to validate the JOT token that's been issued by Clerk. And we also have to listen for Clerk's webhook event so that we know when a user has been created, updated, deleted, as well as when there's been any changes to the organization, like when you've invited a new member and changed their roles and so on. And of course, for all of that to work, we also need to be able to authenticate against the user against the GitHub, and to also install the our GitHub app on the repos. So the front end also have to integrate with the GitHub API directly as well. And then also to get paid, which is important, we also have to integrate with Stripe. So we have webhooks to listen for payment-related events. So we know when someone has created a subscription, canceled the subscription, when they have added new users, so they have to update the subscription, and so on and so forth. So basically, the whole system is a mix of some webhook API to know when something has happened in the other systems, as well as the GraphQL API that is going to be there to support the front end. And of all of those things you see on the screen, there's basically one Lambda function that is doing all the cool AI stuff and uses Bedrock to review your code. And in the context of what we are doing, a big challenge is that we are dealing with customers' source code, which is pretty much very sensitive data, is their secret source, right? And we also have to deal with large files or large PRs that have changed lots of files, both of which is going to push us against several limits, either with the LLM itself and GitHub as well. And we'll talk more about that in a minute. And we decided to go with Amazon Bedrock to access the AI models in large part because of security, because again, we are dealing with customers' source code, which is the sensitive data. So we want to make sure that all the data that we handle, both the input and output, are securely stored and encrypted, and not just exposed to the whole world in plain text, as happened with DeepSeek pretty much right after it launched. And so with Bedrock, there's another thing that's really important to us, which is about the privacy. And as Bedrock says, it is FAQ is never going to share your input and output with anybody else, or nor would they actually use your data to train the other models. And because we also have a fallback to Anthropic, so we had to make sure whatever privacy guarantees we get from Bedrock, we can get the same from Anthropic as well, which luckily for us, it is the case, as far as I can tell, based on their own privacy policy as well. And we also liked Bedrock because it's serverless and there's no need to manage any clusters or servers and to secure them. And because it has got this token-based pricing, which at our current level of usage actually works out a lot cheaper than to say pay for a cluster of GPU machines that are at a pretty high hourly rate, even though we don't have that much throughput. So soon after we launched last year, DeepSeek R1 was released, and basically it was able to offer a really good level of reasoning at a really, extremely low price point. So compared to what we were paying for Bedrock to access the core models, it's actually pretty amazing how cheap it is. So DeepSeek, very, very cost efficient. However, if you use the DeepSeek's own API, then your data is going to be stored in China, and that's going to be a hard no from a security point of view for our customers. And also the fact that DeepSeek's privacy policy says that they might use your data to train other models, as well as quote unquote other uses. So again, that's also a big red flag for us as well. Plus the fact that they are an AI research lab and not at all an infrastructure company. And as we've found several times, there's been a few big outages or issues with DeepSeek since it launched. So they are fairly immature when it comes to operational stuff. So using their API is definitely not an option for us. Luckily, since March, DeepSeek R1 is now also available on Bedrock, and you can use it with token-based pricing as well, which, as you can see, is about 2 to 3 times cheaper than to use Claude Sonnet on the Bedrock, which was our default model when we launched. Even though it's still quite a bit more expensive than using DeepSeek's API directly, basically you are paying for Amazon's, operational excellences, as well as its ability to provide much better security around your data and provide you with the privacy guarantee that's actually important for you when you're dealing anything that's important. Plus, Bedrock has got a bunch of other built-in things, including a managed RAG, support for agents, as well as being able to do evaluation, basically run a set of tests that you provide against models to help you identify which models are best for your use case. And also got a really nice feature around the guardrail so that even though you may be able to jailbreak individual open source models that you run yourself, with the guardrails, you can find that you have a much better guarantee when it comes to stopping people from jailbreaking your models, which is important if you're doing any kind of like a chatbot and things that where you accept the user input to your models. However, so there's a lot to like about Bedrock. However, because it's an AWS service, you can't access other proprietary models like Google's Gemini, and the 2.5 Pro is probably the best coding model right now that we have. Of course, that's Google, so you can't use it on the AWS. And also, not everything was hunky-dory with Bedrock either. Just before we launched, we actually had a problem, which was the Amazon AWS changed our quota throughput on the Bedrock to 0, which basically meant we couldn't use Bedrock at all across all of our accounts. And this didn't just hit us, hit a lot of people. So there was a big Reddit thread on that. And we went through the AWS support. They couldn't help us. So I did the only thing that I can think of, which was go on social media and complain. And that actually got someone from AWS to help and unlock our accounts. But this was a big issue that affected many people. Since then, I found out because of the AWS context I have, what the issue was, why this happened, and why this affected so many people. But publicly, they haven't said anything. But if you want to find out about what happened, feel free to come to me afterwards. Happy to explain. But that was the moment that we realized that we really needed to have some kind of fallback in case there's any issues with Bedrock. And later on, we also learned there's other limitations, which are some of the things that we've learned through building the whole process of building this AI-based, AI-powered code reviewer. So if you ignore all the UI side of things for a moment, our backend is actually really, really simple. We basically have some kind of a webhook handler that takes the event from GitHub, and then we call the GitHub API to fetch your file changes, and then we analyze them with AI, and then we provide you some feedback by making comments against your PR. So obviously, there's a lot of asynchronous data processing on the backend, so we need to have good observability, and that's where Lumigo comes in. So we had Lumigo hooked up to our backend Lambda function, so we can see when the event triggered our API and triggered Lambda function, and we made a bunch of API calls. So this is a condensed view because the actual number of API calls can sometimes be really, well, a lot of them, especially for large PRs with lots of small file changes. So we end up having to call so many different services to both GitHub as well as to Bedrock. So when it's fully expanded like that, it's kind of you can't really see what's going on. Another thing we often see is that, sometimes with the Lambda function, you have a maximum timeout of 15 minutes. And when there are so many API calls, especially to the Bedrock models, sometimes they take a long time to respond, sometimes taking 20, 30 seconds to analyze a single file. So you often find that your function can time out. And so one of the nice things about doing asynchronous data processing with Lambda is that you get that built-in retries. And we have some mechanisms to allow you to, on a retry, skip some of the things that skip the files that we have already analyzed. I'll talk more about that in a minute. And so with this on the Lumigo page, I can then see, okay, on the retry, this PR was successfully processed because the first time it timed out, but then when we reprocess, we're able to skip a lot of things that we already done in the last attempt. So large PRs are like this, going to pushes us against many of the limits. And if I'm really honest about what we've done, most of the work we did was not AI related. AI is probably about only 10% of the work we did. The other 90% of the work, actually most of the development work, was around connecting the AI model with everything else, as well as working around all the limits and edge cases you get for when you're working with LLMs today. So a lot of the benchmarks out there are focused around the reasoning abilities of these models, which obviously is important. But when you're building AI-powered applications, the constraints around the context window size, the maximum response size, as well as API rate limits, those are things that are also very important as well. For us specifically, the size of the context window also decides whether we can put the whole PR into one prompt, or do we need to, say, use one prompt per file to analyze individual files, and or do some kind of a batching. One of the big lessons we learned pretty quickly was that those publicized context window sizes are mostly a lie. Even though a lot of models say they have a million token context window, and how they can use the needle in a haystack test, benchmark test, to show how they can have like a 99% accurate recall when you have a large context window size, which sounds great. But whenever I try those AI chatbots, I use a lot of them all the time, it never quite matches your real world experience when I try to upload, say, like a large PDF and ask questions to a chatbot. Things about the things that are content that's in the PDF, they are really bad at answering those questions. So I always had this like sneaky feeling that something's not quite right with those benchmarks, because it turns out the ability to recall information from a large context window doesn't mean that you can actually make sense and reason with that much data. So it's like if you have someone who can recall pi to the thousands of digits, but don't know how to use pi to calculate the surface area of a circle. So being able to recall things is one thing, but being able to reason with data is another thing altogether. And since then, there's been the new benchmark called the Fiction Live Bench that actually tests a model's ability to reason with large context window. And what they found was that for most models, even when they can support, say, like a million token context window, they can only reason with about 30,000 tokens. And after that, the model's reasoning ability just crashes, just collapses completely. That is, all the models except the Gemini 2.5, which, 2.5 Pro, which actually performs pretty well even when you get a bigger context window. And the reason for that is because that model runs on specialized hardware that's optimized for reasoning with large context windows. Everything else, as you can see, just degrades really, really quickly, even before the 30,000 tokens. So that's pretty much what we found, that when we try to squeeze all this data, the entire PR, into a single prompt, it just can't really do much with those that data. It just gives you bad, really bad answers. So context window, cost, performance, those are all important considerations for choosing the right model. And picking the right model is kind of half the battle. I mean, you spend, like I said, about 10% of my time actually just working with AI and researching, testing different models, tuning our prompt, and so on. The rest is probably all around the working against those limits and how to still build a good user experience based, despite those limits. A big limit that we keep running into was API rate limit. For example, on the Bedrock, the default throughput you get for Claude 3.5 and now 3.7 Sonnet is about 50 requests per minute. So if you've got a large PR with lots of different files and you are reviewing a single file with a single prompt, then you can run into this limit very, very quickly. You can raise this to, say, 1,000 per minute if you get your account allow listed on AWS. And there's also several things you can use on Bedrock. For example, they support cross-region inference. So essentially, you can send your request to, say, the US East 1 region, and you can distribute across the US East 1 and the US West 1 regions so that you can essentially double your throughput for Bedrock and for Claude. But that's still not enough, right? When you've got, say, potentially a large PR or a spike of traffic, then you can still run into those limits, which is why we, besides using the cross-region inference, we also limit the number of parallel requests a single PR can make to Bedrock so that one person or one PR can consume all of our available throughput, that nothing else gets processed for that whole minute. And also importantly as well, we have a fallback, I mentioned earlier, to Anthropic's API, but we also have fallback to other less powerful and also cheaper models that have higher throughput limits, so that if we, that our preferred model, which at the time was the Claude 3.5 Sonnet, wasn't available based on the throughput we want, we will also fall back to Claude 3 Sonnet and Claude 3.5 Haiku, which are cheaper, less powerful, but have a much higher throughput limit than the Sonnet. But also there's also Nova, and we also added the DeepSeek as well, R1 to the mix, because again, they have a much higher throughput limit on Bedrock, but also some of these models are great for cost control as well, because they're much cheaper per token compared to Sonnet 3.5. So one of the things we can also do is use that for, say, free users versus paying users, so that we may give preference to paying users so that they use a better model, a more expensive model. And talking about cost, this is still probably one of the big lessons we learned, especially at early as we're building this AI powered code reviewer, is that even though they've been getting much cheaper over time, the LLMs themselves are still kind of expensive. And many people have found the same thing, that even for paying users, people that are paying for using your system, using LLMs, you can still find yourself in a position where you end up spending a lot more than what the customer is paying you. Because a lot of those user-generated queries, especially around code, can be quite expensive because they are, again, oftentimes many large files. So it becomes quite a tough thing to try to build a sustainable business model while still trying to offer a competitive price, especially in the space of, say, code reviewer, AI code reviewers, where there are other companies like CodeRabbit, which is probably the biggest one right now, where they've just raised $50 million in the, I think, Series A funding or Series C, I can't remember which one, but company that's spending a lot of money on both AI use, but also advertising. So, and also you've got people like Google and GitHub has also released their own code review as well. So again, it's a very competitive market in terms of where you can charge customers. And so a couple of things we wanted to do, and probably the biggest thing we decided to implement in terms of cost control is just we only analyze the files that has changed, so that we don't limit the number of files and AI prompts that we have to make. But it turns out this was also good for both cost control, but also for user experience, because otherwise you're going to get so many comments on things to your PR that are not related to what you've just changed, which is, from a user's point of view, is actually quite annoying. Another thing we also find is that the AI models that we use are actually really good at picking out small things, things that you probably don't really care about, small things that you are happy to just, it's not a big thing, so we can just ignore. So we also then add this support to say, okay, don't bother me with minor things, only show me issues that are related to security or critical things around performance and things like that. So you can just include like a YAML file in your code base, and that tells us, okay, what issues that you want us to highlight and what issues you don't want us to kind of bother you with. We also have some limits around the free users, so that you can sign up for free, but then you can only make, we only scan I think 10 PRs per month, so that we limit our spending around the free users until they convert to a paying user. And also, lastly, when it comes to building async data processing with Lambda on AWS, one of the nice things you get is that you get this built-in retries and then delta queue support, so that when our, say, function times out after 15 minutes, we get built-in retry. And what we don't want to do, however, is that when that retry happens, we don't want to make the same calls to Bedrock again. So again, we don't want to double pay for things. But also, if the first time you ran, it timed out, if you don't do anything else, you try to do the whole thing again, it's just going to time out again, right? So that's, again, not good user experience, and you're going to see all these duplicated comments as well, because we're making an API call to tell GitHub what's the issue we found. So the way we kind of solved this was to basically implement a really lightweight, durable execution by using checkpoints along the code, so that we avoid reprocessing things and causing side effects that has been done in the last attempt during the whole async processing. Really, the way we implement it was just a few lines of code, really. We have some helper functions that allows us to take some kind of repeatable idempotency key for every single step we want to perform, identify based on a unique ID for every event we receive, but also for the step that we're trying to perform against a specific file. That way, on a retry, we just check the database. Have we done this already? If so, just fetch the result from the last time. That way, on a retry, we just skip over most of the things that we have done in the last attempt so that we don't have to reprocess them and also call Bedrock again for the same files. So at this point, you say, okay, well, you got this durable execution thing that you kind of build yourself. Why not just use AWS step functions? For one, you see a lot of content from AWS around building AI agents and AI workflows using step functions. You can get this similar thing whereby you can build this durable execution workflow using step functions. The short answer is to use step functions, we have to rewrite the entire application to fit into step functions, how it works, and split your code between ASL as well as different Lambda functions. Whereas with the simple checkpoints, you solve the problem with much less effort involved. So next issue is that I mentioned already, latency can often be a problem because oftentimes when you call a Bedrock to say review a single file, it takes 20, 30, sometimes I see like a whole minute before Bedrock responds. This is probably the same. Well, some of the models are faster than others, but some of the models, but the model that we kind of default to, Sonnet 3.5 at the time, did perform on average about 20 seconds for every single request. Which means, our function often tend to time out, especially when we kind of limit the amount of concurrency or parallelism we have per PR, because again, worry about the available throughput. But also it leaves us with Lambda functions running for a long time with a lot of CPU cycles being wasted that we're paying for per millisecond. So that's also kind of awkward from a cost management point of view. So one of the things that's been floating in my head for a while is now once we make the call to Bedrock, we've got all this free time. What we can do, we know a lot of our customers are using the cloud. And so what we can do is run open source static analysis tools on the relevant projects and files. For example, using Chekhov to check your Terraform script or files, or use a CFN nag or CDK nag for anything that we see, it's a CloudFormation project or it's a CDK project. So we can run a lot of local analysis on your source code files, even just within Lambda function while it's waiting for Bedrock to respond. The next one, probably you've all heard about hallucinations around AI models. That's getting better, but it's still a problem. We want Bedrock to give us back a JSON response, and so we always very particular about the prompt that we write. And so with that JSON response, we're able to do a nice formatting around the GitHub comments. We can take the relevant bits from the response and then just slot into the kind of the template we have to make a call to GitHub. And that works 99% of the time, is fine. But occasionally, Bedrock just like, nah, here's some plain text response, have it added. So of course, when we get that, we're gonna just try to parse it with JSON and it will fail. But luckily, on the retry, this tends to fix itself because it happens very infrequently. So you're not gonna see the same file, multiple calls to the same file, still gonna get back in plain text. But there's also sometimes, that's the kind of problem is quite easy to fix, but some other hallucinations are harder to kind of detect and verify. For example, sometimes we include a reference to kind of known problems like OWASP top 10, for example. And sometimes you just get back links or things that doesn't exist. You just imagine some okay, this sounds like an OWASP thing, which creates a new link or a code that just doesn't exist. And sometimes, even funnier, that they just generates a random line number that was in the PR. We have no idea where those come from. But luckily, this problem also quite easy to fix on a retry, because when you try to add a comment to a line that doesn't exist, GitHub API just goes, nah, not happening. Where it gets tricky is when you put a line, a line number that doesn't that's on the wrong line. Sometimes you get PR comments that's okay, what do you mean? That's not what you're talking about, what the issue is. So you get weird things like this, which are kind of hard to detect. But also even worse than that, the example I showed you earlier, the first example about the potential remote code execution risk with using YAML.load. Well, it turns out that doesn't exist anymore. It's not a problem since 2021 with the JS YAML library that we were using. And the suggested fix use YAML.saveload. That function's gone for about 4 years by the time we launched this. And the reason for this particular problem is that, well, we are analyzing a single file at a time. So the model doesn't have the full context of your code base. It only sees, okay, this file you've changed, these are the lines that you've changed, and you asked me to review this. What we can do to fix this particular problem is by using RAG, which by just giving the model access to the entire code base, and then say, please, based on the fact that no, this is the current code base, here are the files that we just changed, here are the changes, please review this code, change based on that. We notice that when we try to do this, we can get better results. However, as I mentioned earlier, these LLMs are still quite expensive. Every kind of new feature, every nice thing you add, using RAG, using agents, those are all going to increase your cost when it comes to AI, your AI use. And so it becomes even harder for you to build a sustainable and competitive business model. And again, a lot of it comes back to the fact that all these AI models, they're heavily subsidized by basically VC money. If you don't have VC money to back you up and you're building things that are using AI a lot, it's going to be quite hard for you to build a business model around that. And we've seen a lot of companies struggle to do that until they raise money. And so those are the lessons I took away as we build this AI code review thing. And another thing is, we didn't actually spend that much time. I was working with this client. I was building by the hour. So I only spent about less than 80 hours to go from idea to production. So we were able to iterate and launch quickly and learn a lot of things in the meantime. I'm sure you got questions about some of the decisions we made and some of the business challenges that we face as well. So if you've got any questions, happy to pick it up now. If you don't want to ask it in public, you can also come find me afterwards. I'm going to be around the place. So yeah, feel free to come to me and ask any questions you have. So yeah, thank you very much. If you've got any questions, happy to take it now.